Hi, so today I want to do a live coding demo. We're using the Google Code Jam. This will be for the qualification round 2016, and it will be part A, counting sheep. So the problem is as follows. Beatrix Trotter, the sheep, has devised a strategy that helps her fall asleep faster. First she picks a number, n, then she starts naming n, 2 times n, 3 times n, so on, whenever the names of a number she thinks about all the digits in that number. She keeps track of which digits, 0, 1 through 9, she has seen at least once so far as part of any number she has named. Once she has seen each of the 10 digits at least once, she will fall asleep. Beatrix must start with n and must always name 1 plus n, I plus 1 times n, directly after I times n. For example, suppose that Beatrix picks n equals 1692. She would count as follows: n equals 1692. Now she has seen 1269. 2n is 3384. Now she has seen 1, 2, 3, 4, 6, 8, 9. 3n is 5076. Now she has seen all 10 digits. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and fall asleep. What is the last number that she will name before falling asleep? If she will count forever, print insomnia instead. If she will count forever, print insomnia instead. So input, the first line of the input gives the number test cases. T test cases follow. Each consists of one line with a single integer n, the number Beatrix has chosen. So output we will write is the case number x, where x is the test case number, and y is the last number Beatrix will name. Okay. And n will go from 0 to 200. Okay, so the limits t is from 1 to 100. What is t? T test cases. Okay. Let's see. Okay, and so let's look at the cases. It's good to look at these cases. It'll give you a better idea of what's going on. So insomnia will be 0. Pretty much 0 is the only thing that will cause insomnia. And I looked earlier, there's no negative number, so it's basically 0 to positive infinity. It's the possibilities. Let's see, case 2 is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because, okay, yeah, that makes sense. Case 3 is 90, so it'll be 2, 4, 8, 16, 32, 64. Is that 2? No, it's 2. 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8, 2, 4, 6, 8, 10, 12, and then it doesn't get to digit 9 until 90. That makes sense. So 90. Okay, and Beatrix will name. So 1 times 11 is. So this is basically 99, but then it has to get the 0. So 110. I see. Okay. I think I get what's going on now. So I think our thing is list of found numbers. This will be an empty list to start out with, and while the length of list of found numbers is less than, this is not needed. It needs to see programming, so while length is less than 10, and then we keep doing something. So let's write functions. So our definition is count sheep, I guess, input file, although I guess our modules are counting sheep, but anyways, with open input file as input file, print line. Oh wait, so we want to skip the first. Yeah, so the first line is always how many lines it's going to be, which is 101. And I think we want to skip the first line always, but we'll see. I'm thinking like we either skip the first line or else we have to use a loop and use the first line as a loop so that, might be wrong, but it doesn't get to this last line here and do something weird. Because once it reads this last line, it's basically going to be, does it read the last line? Let's see. And then there's going to be the, get rid of that. Did something not happen? Oh, it's because of this. Okay, so it didn't read the last line, I don't think. Oh well, let's see. Alright. Oh, so this should be the start, basically, is that int. What should we call this function? I guess find numbers, find all digits, and we'll take in a start, and list of, let's just copy this here. Okay. And so we want to, I think, treat this as a string instead of an integer. So actually this will not be int, it'll be string. And we want to traverse, is it traverse or is it whatever? Yeah, traverse the string until, and we know that they're all integers. So let's see. So number equals to start, and while the length is less than 10, for x in start, or sorry, number, if the integer, if, let's just say int x is int of x. So if int x not in list of found numbers, list of found numbers dot pen int x, okay? And then we want to now multiply current count is equal to 1, is equal to 0. So we want to now equal to 1. So no, sorry, the first time we want to multiply by current count, it should be 2 times that. So we start at 1. We might even want to start at 2, depends how we want to do this, but we'll just iterate here. So we now it's at 2. Oh, or we could do it at the end, okay. And then number is equal to string int times, sorry, string int of the number times current count. And then we want to return number. I don't know if this is actually right. This should actually come before because we want to break out the loop before that occurs. And this will start at 0 now. So the first time we multiply by 1, then we do the loop. it'll break out if we found all the numbers. Didn't return a number. So let's see, print. This is just debugging print statements, print line, as well as the find all digits start. Let's see if it'll actually run or not. And I think it's paused in the while loop for some reason. Yeah. I want to print X. Just see if, oh no, that's not good. Okay, I forgot. So the first case I think is insomniac, and that is probably why it didn't, yeah. So if int start equals 0, return insomnia, I believe. Insomnia. So return it if it's 0. I think that's the only case it'll be insomnia. Let's try this again. Okay, we actually got it to run. Why is it 3,300? What is that? Oh, because I have this here. Probably. Yeah. Let's just try some test cases. So find all digits that we know answers for. So 0, let's see. 0, 1 to 11, 16, 92. 0, 1 to 11, 16, 92. And that will be, let me take this off. Let me print this or else we get nothing. I wonder why it didn't, you know what? It's because I'm printing the line and not the strip line. So that's why that's why you see this. But why is 1 so high? It shouldn't be that high. It should have been... Yeah, anyways, okay, let's try this. Yeah, that's not right. It should be 10. Number is 10. Let's just try the first test case. Number's 10. Print X. Let's see, why does it keep looping then? 1, 2, 6. I don't know about 6. Let's print number. Let's see if it's looping correctly. Oh, you know what? It's not multiplying it by, it is multiplying by current count. Oh, well, let's see. 1, 2, okay. So when it's 2, oh, because number keeps changing. It shouldn't be changing. Oh, I see. I see. So current numbers, and this should be current number. What did I have it before? Yeah, number. Okay. Let's see if that. No. 1, 2. Okay, so this should be incrementing though, right? No, so I'm putting the wrong thing. Okay. This should be okay. 1, 2, 3, 4, 5, 6. Okay. So let's do our test cases. hopefully this is the last time. 1 to 11, 1692. 1 to 11, that's, oh, kernel. It should always go through this loop at least once. So kernel, we don't have to worry about instantiating it outside the loop. But kernel is 10, 90, 110, 50, 76. So I think I got it right now. Let's just fix up some of this code and let's just do their format. So case number. Sorry, case number. Count equals 0. Count equals 1. Cluster count. Forgot the I think I should use format better, dot format, but it's a quick and dirty. Oh geez, it took away. Well, we're only caring about what it looks like. Okay, that looks good. And yeah, so that's all. Wonder time-wise how I did. You can check. I'm not sure how to check, but hopefully that was quick enough for you guys. And this will be on my GitHub if you want to check it out. Thanks.